is Blessing Taiwo, and a technical specialist from WipWare. In this training video, I will be giving a detailed explanation on how to use WipFrag. Either you are having the first interaction with this software, or you are used to what the software used to be before. This video will be a guide to you. It's going to cover a lot of topics which will be of interest to you, and this video will be a kind of interactive video in such a way that if you are new to the software, you can easily have knowledge on how to use the software. And I'm going to provide a guide to image acquisition as a blaster man. How can you acquire your image after the blasting? What are the best practices that you can include in taking your picture? What are those things that you need to put in mind? So this video is going to be giving a guide to that process step by step. Let's begin the video by a quick introduction of what I'm going to cover in this video. In this video, I'm going to cover image sampling for blasting assessment. Basically, it could be assessing the blast on site. It could be assessing the blast after you've moved the material from one point to another, irrespective of wherever the material is. This video will give you a guide on how to take the best image and how to do the analysis on your mobile phone, on your Windows computer, or in any version of devices you're using. So the sampling procedure will start by explaining how to take an image in a surface mine. It's going to expand to taking image on underground mine, and taking image either as terrestrial image or as drone image. Then I'm going to explain to you the different type of scaling approach you can use, beginning from in-app, that is auto scale approach, using dual scale, single scale, among others. And I'm going to take you, the second part of this video will dive into using the software, then interpretation of the results from the software. I hope you find this video useful, and if you have any question, feel free to reach out back through the mail that I've provided this video through. Things you can do with the software now that you have created an account and you are looking forward to improving your blasting. What are those things that the software can provide data for you on, and what you can do with the data? The data from the software provide information on how to reference your blast, how to check your blast in compliance to your safety standard, compliance to your production standard, how to check your blast in assessing the quality so as you can control any region of the blast that is not meeting your target. It's also helped you in oversize detection. You might sometimes be having issue with boulder in the mine, so this software will give you information about the region where the boulders are coming from, what is the size of the boulder, what is the shape of the boulder, what region of the blast is contributing to this poor performance in your blasting. Also, you can compare multiple products using this software. Also, if you are an explosive company and you're looking forward to testing different of your products, the result from this software creates an interface that allow you to compare multiple blast results and see the improvements that has been made as a result of changing explosive, changing parameters, among others. Checking your blasting if it is compatible with your crusher. This is one of the things also you can do with the results from this software. The software have a lot of tools that allows you to do this kind of comparison or checking the crusher gap with the material size class. So you can use different approach in this state, which I'm going to be explaining in the demonstration version of this video. What is the approach to the image analysis when you're using WipFrag? The same thing being done in the lab is what the software is replicating, using a virtual sieve, then assessing the material in image version. So you are expected to take the picture of the material you want to analyze, then the software is going to do the assessment, giving you ability to check this material size class with 25 sieve set, which is adjustable. So you have the sieve set just as you have it in the lab, where the bigger mesh is at the top and the smaller mesh is at the base. So this software also mimic this approach by setting up 25 sieve set that can assess the material in the image and give you the percentage passing on different sieve and the percentage retained on different sieves. So one of the advantage of this is that you can edit these sieves, you can define the sieve set, you can include your primary crusher, you can include your secondary crusher inlet and other size class of interest when you are doing the analysis. The software helps you in checking your blast. You've planned the blast, you've executed the blast, then the software gives you avenue to check whether the blast is compatible with your production targets, compatible with your blasting cost target, with safety and with downstream operations. So these are things I will be giving you more insight on when I start doing the demonstration on the software. A brief quick about WipWare. The company has been in existence since 1986 and we are based here in North Bay, Ontario. And in case you like to reach out for support or you have any question regarding how to purchase the software or how to apply the software to a specific application in your mind, feel free to reach out to us on this mail, which should be of interest to us to help you to ensure that you take your operation to the next level of your desire. The workflow for the software, you begin the usage from taking image. You need an image of the material you want to analyze. So you can take the image in different ways, which I'm going to explain in the next slide. Then you need a scale object, or you can take the image without scale. When do you take the image with scale and when do you take the image without scale? What are the practical approach to these procedures? I'm going to explain this in the next slide. Then after that, the software dictates the edges of each of the fragments and give you an estimation of what the size of the material is. Then you can edit the size classes, that is the edges detected by the software in case when you have poor image quality and you need to make editing. So we have up to like 8 editing tools, which I'm going to show you in the demonstration how to use each of the tools to ensure that you have your analysis well performed and well assessed. Then you can generate the particle size distribution curve aftermath. Taking the image, you have different ways by which you can take the image after the blast. You can decide to take the image with your mobile phone, which is one of the devices that is always with you. It's not an external device like if you want to take with digital camera, you need to get a camera for sure. But taking the image with your mobile phone have additional advantage, which is leveraging on the auto scale capability of the software. When you take the picture in app, that is, you download the software on your mobile phone and you take the image in the software, then you have the advantage of auto scale, which I'm going to show you a video on how to do that. Then you can take the picture with a digital camera, that is, you have a camera available on the mine site, then you take the picture. If you're taking the picture with your digital camera, you need to put a scale object on the mock pile. What is the best scale object for this kind of work? I'm going to show you different type of scale object and different kind of scaling approach in the next slide. You can also use a drone. If you have a drone in the mine, you can launch the drone after the blasting and take multiple images, which will cover the blast cap, and the software can easily stitch these images together to create an auto mosaic image that will allow you to do your analysis on the go and accessing the full blast using drone image. Also doing analysis underground. Maybe your own application is underground. The software is also compatible with this application, which I'm going to show you the guide to setting up lights to ensure that you have a good resolution in underground mine application. Now, taking the image, as I've mentioned earlier, most of the time you might see people talking about using scale objects. And what is a scale object? A scale object is anything you place on the mock pile and you take the picture with it, which will serve as reference for the software in assessing the sizes of other particles that appears in this image. To ensure that you have a good scaling object, I'm going to go through different scaling approach and the best scale material to use for your analysis. So after the blasting operation, you want to move to the mine after the all clear sound has been alarm has been sound. So you want to move close to the mock pile and place a scale object on the material if you are not taking the picture in-app. So a scale object can be a single scale, that is, you place a single bar on the mock pile, as you can see in this image. So in this image, this is called dual scale, but for a single scale you have only one of these bar on the mock pile. When do you use a single scale and when do you use a dual scale? A single scale is used when you have the mock pile being casted on the flat ground, that is, you are not having this kind of mock pile that is slopey. So when the mock pile is not slopey, you use a single scale, you have a single bar. But when it is slopey, you use dual scale in order to account for any effect of magnification. That is, when the object is far away from you, it appears to be small, but when it's closer to you, it appears to be bigger. So that kind of effect, which can be a form of systematic error input into the result, can easily be eliminated with dual scale. So selecting the best scale object, you don't want to go for balls. Selecting ball or using element for scale objects has a lot of demerit issues. One of the issue with using ball or something circular or round shape objects is that when you have the ball on the mock pile and you move far away, the ability to detect the actual diameter of a round ball in the image becomes almost impossible. Therefore, you can easily mix one or two or more pixels when you are trying to highlight edge to edge of the ball. You want to go for something like a range rod or a meter stick that you can easily identify edge to edge when you are trying to trace the scale in the image. So for this sake, you want to avoid using ball or anything circular that can be difficult in identifying edge to edge when you are doing the analysis. Then using the auto scale. What is the advantage of the auto scale? As I've mentioned earlier, if you have your mobile phone with you on site and you have the software installed on the mobile phone, so you want to open the software and use the software to take the image. This approach is called taking the image in app. So when you take the image in app, then you have the advantage of using the auto scale. And how do you take the picture in app? So this video is explaining how to take the picture. When you get to the mine site, you open your mobile phone, open the software, then have your camera pointed to the mock pile. Then you stand at a distance such that you align that green frame to the base of the mock pile. So when the green frame is aligned to the base of the mock pile, you can proceed and take the picture. Then taking the picture, you can proceed with your analysis. Now in that, you can see the software can easily identify the edge of the material using the auto scale approach, which makes things more easier. Things to consider when you are taking the image. These are things to avoid and things to consider when you want to take the image either in app or with your digital camera. The first thing you want to make sure you avoid is walking on the mock pile. You don't want to walk on the mock pile. You don't want to get too close to the mock pile in order to be able to take good quality image. What happens when you get too close to the mock pile? When you get too close to the mock pile, then you kind of limit the image area to a specific region in the blast. That is, you need multiple images to cover such blast because you are too close to the mock pile and those few fragments is being represented by a single image that you're going to take. Then also you want to ensure that you use a specific sampling approach. If you are doing a continuous improvement study, maybe you are having issue in the mine with maybe the design and you want to make adjustment to one or two designs to see how it's going to affect your fragmentation. So you want to use a system, a kind of approach that allows you to replicate the same thing in each of the samples that you'll be taking. Another thing is that you want to take good quality image. I like to emphasize on this. Take good quality image. When you take good quality image, then the software will work faster in getting the edges of each of the fragments. When you take the image, consider the image as something that the software will be interacting with to discover the edges of each of the fragment. So if the image you have captured is in such a way that when you print this image out and you can easily use human eyes to delineate, that is, highlights the edges of each of the fragment, then that is a very bad quality image. So take a good quality image, then the software can use an automatic approach in editing, in discovering the edges of each of the fragment. In situation where you have a poor image, then you might need to do a lot of editing, which you can easily use the manual editing tool to make correction to. But in most cases, if you have a good quality image, you might not need to do any editing after the software detects the edges of the fragment. Another thing is that you want to avoid taking the image sample early in the morning or late in the afternoon. I'm going to show you an example of this kind of image that was taken early in the morning, and what is the disadvantage of this kind of image. So you want to avoid this kind of scenario, and you want to make sure you don't waste the resolution of the image on the ground. So I've seen scenario of people using their mobile phone to take the image, and instead of concentrating the image area on the mock pile, they move far away in such a way that they have the sky and the pit floor included in most percentage of the image area. So you want to avoid that. I'm going to show you an example of that also. Then you want to make sure that you stand at the right distance. What is the rule of thumb in standing at the right distance? Any distance you are standing where you can take an image such that 20% of the image area is occupied by the biggest fragments in that mock pile. So if you take any image and you want to satisfy the image to be at the right distance from the mock pile, it must be such that single particle, the biggest particle in that mock pile, is only occupying 20% of the image area. So that's a good position to stand. Taking image with drone, what are those things that you need? I want to emphasize on this that you don't need an external app to stitch the images together. The software is going to create an auto mosaic image from the multiple images that you have captured with your drone, but you have to follow some steps to ensure that the image is taken in the well approach that we want it to be taken. So what you need to do first is to get any of this app, the drone deploy app or the Piece 4D app, which will allow you to set the flight path and define these parameters, which I'm going to be explaining in a few minutes about drone image acquisition. The first thing is that you want to set the drone image, the drone camera, to be facing 90 degrees. We want a bird view of the mock pile. So you have the opportunity to adjust this on any of these apps when you are defining the flight. Then another thing is that you want to set the front and side overlapping of each of the images that will be taken to be 80%. So 80% overlapping will help to reduce any form of optical distortion. Then a lot of questions always come from people, our users: what is the best height to fly the drone when I'm taking off the drone? So on the drone deploy app, you have an option to, you have a tool that will allow you to set the altitude. So we recommend flying the drone between the range of 30 to 60 meter height, depending on your pit bench height. So if you're having a kind of mine whereby you are starting the mine afresh, then you want to fly the drone at maybe 30 meter to be able to take a good resolution image and also cover enough area in a single image. Then another thing is that when you are defining the geofence, that is, the geofence means the area where the drone is going to fly through and take the picture. You want to make sure you set that geofence just to cover the blasting area. So this idea of setting a flight path will help you eliminate one of the major concerns of drone flying to you want to avoid taking a picture from other properties. You want to limit the drone image to the mine site. So with the flight path or the geofence, you can set this geofence just to cover the blasting area. So you want to follow this procedure to taking image. If you have any question regarding this, feel free to reach out to me, then I can set up a meeting to explain in detail to you or to your team. Then these couple of slides will be showing you good image and bad image, what makes an image to be a good image and what makes an image to be a bad image. First thing I want to emphasize here is that a good image is a kind of image where you can easily see the scale objects, where you can easily see the particles that you want to access. So, and also you are taking the image in such a way that you focus the camera on the multiple and the camera is at the right angle and you are standing at the right distance. So in this first image right here where I have my pointer, this is a good image because I can see each of the particles, then I can see my scaling object. Then in this case, dual scale object is applicable because the material is slopey. Then this second image is a bad image, that is not good enough for image analysis because of these following reasons. The first thing is that the image is blurred. We can't see the fragment at this region. And the second thing is that the person taking the image is far away from the multiple. This is the multiple right here, and taking other area like the ground and the back of this tunnel makes the image quality to be a bit poor in this scenario. This is another image, a good image, and this is a bad image. A bad image because the person taking the image is too far away from the multiple. The multiple is up there, and moving closer to this multiple will have been of advantage. Therefore, you can easily see each of the fragment. Then wasting the image area on sky and on ground will have been avoided if this individual have moved closer to the multiple. This is another example of good image, good scaling approach. You can see the scale parallel to each other, almost parallel to each other. Then the image is clear and you can see each of the fragment. But compared to this image, which is very blurred, and the blasting region was not focused on in this image, so you want to avoid that kind of mistake. Good image, good contrast image, good scaling approach, and good timing. But compared to this image, you can see the scale object is very difficult to identify. Then you can see the shadow cast of each of the fragment on the multiple. So you want to avoid that. To avoid that, you want to take the image in the right time and you want to stand at the right position. Then one of the frequent asked question is that if I have a large blast, like a very big blast, do I need to move far away from the blast and take the whole of the image in the whole of the blasting area in a single image? You don't need to do this because the software has the ability to combine multiple images. So you can take multiple images from the blast, just focus on one side of the blast at a time, take a good quality image, then move to the other part, and take these multiple images. So when you are doing the analysis on the software, I'm going to show you how you can mesh these multiple images together to create a single analysis, which is which can replicate the single blast that you are assessing. So instead of moving far away, as you can see, we hardly see what is at the top, we hardly see what size are those materials. So you want to take an image in a particular region and move to the other region and take another image. Then if you have a very big bench, then you might consider using drone, so that you can cover the whole of the blast. So in their own drone, the whole blast can be seen as an auto photo, which you can proceed your analysis. Then lest I forget, if you are using drone, you don't need to put a scale object on the multiple. The software will use the geotelf information of these images to get a scale reference based on your bench width or based on your bench floor length or the likes, depending on the kind of images you are importing into the software. Then taking image underground. This slide is just explaining the best practice to take a good quality image underground. One of the challenge with underground image analysis is getting a good quality light. So you need to set up lights to ensure that you illuminate the area where you want to take the picture. Yeah, questions always come from people asking about using camp lamp or using torchlight. You want to imagine this image where just a single light direction. The issue with using cap light or using a single light is that you have some part of the image highly illuminated and other parts having a shadow cast. So what do you do to eliminate this? To eliminate this, you want to have two sets of lights, one light at your left and one light at your right, And with that, you want to focus each of these light at 45 degrees to the material. So you can see this light is facing 45 degrees and this is facing 45 degrees. So each of the target setup can easily eliminate the shadow cast. And you are considering getting a light if you want to, if your analysis is underground. So I have a set of lights here, which is majorly for the application of underground light setup. So this is a portable LED lamp which you can use for image acquisition underground. So it works quickly and easy to use, in sense that you don't need to get a big lighting system. Everything fits into this bus. So if you need information about this kind of light and how you can get it set up, I can provide more information on request. So if you have any question on that, you can always ask me. So you can see the lighting system. So here, this light, and the other here is the second light. So these two lights can easily illuminate the mock pile underground. And here is a tripod stand for the lights. So you can use this stand to hold the light in the underground. So you have the lights fixed into this this tripod stand. So this can easily stand at the left hand and the other one at the right hand. Standing on its own, it has a base. Then you can adjust the length. So you can easily adjust the length of this by pushing. If I push up, so I can adjust the length of the light easily. Then another thing that another advantage of using a light setup is that when you have the light setup, shadow cast from the left will be eliminated by the light from the right. So this kind of light is easy to use and is very portable. You can take it all alongside with you when you are going into the mine. So then as I've mentioned earlier, everything fits into a single bus. So everything fits into this bus, which you can take with you when you're going to the underground. Then comparing the previous software to the current state of the software, as you can see, the previous state of the software used what is called classic edge detection, but the current state of the software used what is called deep learning. And as you can see on the screen, this is the demonstration of the difference between these two approaches. The first approach, which is the classic edge detection, have one thing in common. What it has in common is the issue with disintegration and fusion error. Disintegration error is when an image analysis technology is identifying multiple a single fragment as multiple fragments. That is breaking the fragment into multiple sizes. Then fusion error is when you have two or more fragments combined together as a single fragment. So in such case, you might need to do multiple you might need to do editing. So you can use the editing tool if you are using the classic edge detection, but with the deep learning edge detection, this will easily be eliminated. So a lot of this will be corrected automatically. As you can see, this is comparing the performance of the classic edge detection with the deep learning edge detection. So the classic edge detection is underestimating the particle size, while the deep learning is making correction to any form of error that is coming from classic edge detection. So these two approach is available on the software. You can switch to use the classic edge detection, you can switch to use the deep learning edge detection. So this is available on the software and you can easily select this. Sampling approach. What are those things that can help you in making the best decision in sampling? So the first thing that you want to ask yourself, like a couple of questions that I have here, is that what percentage of the material do I need to be statistically valid? What percentage of the blast do you need to take images from so that you will be statistically valid that you've covered the mock pile? So if you are doing a kind of study to assess the stemming region of the mock pile, so you want to take multiple pictures of the blast pile cap, then this will give you a satisfying information about the stemming region. Then if you want to do a profile assessment, then you want to take multiple pictures as the loading operation is going on. Then another question is that what percentage of the material does each image sample contains? I have a lot of people asking me questions about how many images do I need to take? Like, do I need to take 10 images from the blast? Do I need to just take a single image? So with this question, if you have a very big bench and half of the blast can be contained in a single picture, then you have to take 2 pictures in that scenario. But if 3/4 or maybe 1/5 of the blast can contain just 1 picture, then you need 5 pictures to cover the whole of the blast. So these are a guideline to showing you how you can make decision on taking your sample after the blast. Then you want to consider a sampling approach, especially if you are doing continuous improvement. You want to look up to systematic sampling if you want to keep collecting sample every minute of loading or every minute of dispatching of the material. So these are just an example of sampling strategy that you can implement in your mind. Talking about the results from the software, so these are just an overview of what the data from the software looks like. So this is the particle size distribution curve, and as you can see on the curve, we have in this case you have a specification envelope which is designated by the yellow region. So the specification envelope is an envelope that helps you to track down the performance of your blasting. Then we have the cumulative size curve, which is the particle size distribution curve. So the curve is also an interpretation of how the blasted material looks like. So if you have a kind of curve that is flat, or a kind of curve that is limited within 10 to 1000 millimeter size class, it shows that you have highly uniform material. So these are things that you can use to quantify or qualify your blast. So then when you have a specific size class of interest, you can edit that. So this is the sieve size used to draw the particle size distribution curve, which is editable. Then another thing is that you want to assess the D80 value, the D90, and the characteristic size. The D80 is the size that represents the 80% passing size. That means if you perform any blasting, the D80 value that you see right here is showing the size that represents the 80% passing. That is 80% of that material being that you just blasted is smaller than this size, while just 20% of the material is bigger than this size. Then the characteristic size is the Rosen-Ramler characteristic size, which is also known as the D63.2. So this is called the central tendency. This is the size that defines how the curve is going to be, the region that the curve is going to span through. So then we also have the sphericity. Then we have the uniformity index. What does the uniformity index represent? The uniformity index in this concept is defining how uniform the material is. So if you have a highly uniform material, then you have high rate of N, then the N value will be high. Higher N value shows that each of the material coming from that blast are uniform. That is, the ratio of the width to the length of each of the particles in that blast are close to each other. That is, good uniformity index comes from high sphericity. So having mentioned that, this is just an overview of what the BlastCast model looks like. The software also have a simple model called the BlastCast. The BlastCast helps you to simulate your blasting. Maybe you want to adjust 1 or 2 of the controllable parameters. Maybe you want to change your burden, you want to change your spacing, then you want to check the effect of any change that you make to all these parameters on the particle size distribution curve. What will happen if I reduce my burden? What will happen if I reduce my spacing? What will happen if I change my bench height? So the software can easily show you what might happen if you make adjustment to any of these parameters. So the activating this BlastCast will bring 2 curves to the interface of the chart. So one of the curve is the red curve and the other curve is the blue curve. So the blue curve is the curve that is showing the current blasting, that is the current blasting that we are assessing. Then the red curve is the curve that is showing the simulated blast. So you want to adjust the red curve in such a way that the red curve moves towards the left hand side. So moving towards the left hand side have a lot of implication. The first thing is that when the curve moves to the left hand side, any adjustment you make you are making to the curve that allows the curve to move to the left hand side has a lot of implication. The first thing is that there is reduction in the oversize, there is reduction in the central tendency, and there is improvement there is improvement in the uniformity. So you want to make adjustment to the curve such that the curve moves backward. So then you can also set a specification envelope to ensure that you move the curve from the previous region into the specification envelope. So depending on what you want to use the software for, and we also have other tools which I'm going to be showing you in the interface of the software. This is just a slide explaining to you more about the uniformity index. How does the material looks like when you have an uniformity index equals to 3? When the software shows you a uniformity index equals to 3, these are material characterized by a very uniform size distribution, where the smallest common visible block is about 1/3 the size of the largest common block. So in this case, you can see a highly uniform material where the ratio of the small fragment to the big fragment is 1/3. Then you have a uniformity index of 2 when you have a material characterized by fairly uniform size distribution, where the smallest common visible block is about 1/5 the size of the largest common block. The ratio of the number of largest common block to the small common block is about 20:1. So you can see the differences between each of these uniformity index. So this might be your pinpoint, especially for aggregate production company. You want to produce an aggregate that have high uniformity index, so you want to use that to track your production. These are also an example of other uniformity index for mines that are having issue with fines. So you can easily use this also to track the rate of fines. As you can see, when you have a uniformity index lesser or equal to 1.25, you have more fines as shown in this image. Then you see other uniformity index equals to 1, uniformity index to equals to 0.5. These are material characterized by a very well graded size distribution, where the smallest common visible block is about 1 to 20 the size of the largest common block. The ratio of the largest common block to the small common block visible block is 1 to 15. Area of particles that are too small to be resolved cover over 50%. That is, over crushed material region is up to 50%. That's when you have uniformity index as low as 0.5. Other application of results from the software could be using the DAT with the bond equation to estimate the work index, that is the work needed for a crusher to reduce the size class from P80, that is from F80 feed of D80 to product of D80. So you can use the output of the software to estimate the energy consumption of your crusher. All you need to do is to take a picture of your material before the crushing and a picture of your material after the crushing. So when you have analyzed the picture of material before the crushing, you can easily get the D80, which is also known as the F80 in bond equation, that is the feed size, 80% size of the feed. Then after the crushing, you can get the picture and also access it to get the P80, which is the product D80, 80% passing of the product coming out of the crusher. Then you can get the work index, which is specific, which is unique to each rock. So if you are mining, if you are extracting a mineral like copper or granite or the likes, you can get the work index, which is the WI. So when you get the work index with the results from the software or from our solo system, if you want to have a system on the conveyor belt, you can easily calculate the work index to estimate the work input in your crusher. So this is just also showing comparing blast. You can use the software to compare your blast and to get any kind of improvement check on your blast. Yeah, so these are other example of application that you can use the result of the software to do. So this is showing an image, an automosaic image, and with the automosaic image you can use the GIX feature of the software to assess the blasting on site. So assessing the blasting on site, you can easily see the area where you are having issue, which should be denoted by the red color. So the red zone are area of interest. You want to pinpoint those areas and check what is going on in those regions, so you can easily track the blasting. So these are also further example of using auto mosaic image, that is drone image, you can easily see those areas where you're having poor fragmentation. Then you can trace them down to the GIS on site and see what is going on site. Most of the time on site, when you have poor fragmentation in a continuous approach like this, it might be something is wrong with the blast design. In this case, where you have the back, that is the second to the last roll of the blast, showing this kind of poor fragmentation, it could be that there is too tight budding at this region that is causing this kind of poor fragmentation. It could also be maybe something went wrong during the initiation timing. It could be the design, maybe the stemming. It could be maybe the in situ rock condition. So you can easily know what is going on, and you can trace this down to the site using the GIS option. The software is available in multilingual. You can switch from different languages. You can decide to set the software up for French, set it up for Spanish, for Germany, for Portuguese, Russia, or any kind of language you want to interact with when using the software. Getting the software. Now that you've created an account and you've watched this video, how can you get the best subscription to work for you? You can use the software in 3 major ways. The first way you can use the software is by getting an annual subscription. Annual subscription means that you have access to the software for 1 year, doing unlimited analysis, and also using your subscription on 10 different devices. So if you have annual subscription, you can use this software on 10 different devices. You can activate the annual subscription or purchase the annual subscription directly on the software, or you can also purchase the annual subscription by sending a PO purchase order to us. Then we process that. Then you can get the subscription activated as soon as we receive your payment, or you can go online on the software directly and get this subscription activated instantly. Then you can use the software on a pay per use option. That is, you can buy image credits. Sometimes maybe you want to only use the software maybe once in a month, or maybe your blasting is just once in a month. Then you can get an image credit which allow you to analyze each images and pay with the image credits. That is, unlock the image using image credits. So with that, you can also share the image credit with colleagues. Maybe you won't be on site, you can share the image credit. But with the annual subscription, if you have up to 10 team members, then you can have the same subscription log into 10 different devices. Then another advantage is that you can synchronize analysis. If you have one of the team members taking the image on site with their mobile phone, the software has a synchronizing approach that allows the image taken in app, that is on your mobile phone, to be synchronized to you who is in the office. So you can access this image directly, so far you have access to the same subscription. So you can also use our make frag option. The make frag option is when you want to take the picture and send this picture to us to analyze for you, and you can get the results within 48 hours. So you can use the mail frag, take the picture, send the picture to us. Then when you're taking the picture, you want to ensure that you either have a scale object on it or you take the picture in app. So if you have a scale object on it, you want to identify the size of the scale object before sending it to us. Then when we receive the image, we access the image and check if the image is good quality or in the right order for the analysis. Then we do the analysis and you get the results within 48 hours. But for you to use the mail frag, remember you need an image credit on your account. Yeah, thank you very much for watching the version of this video. So this is the first part of this video. The second part will be on demonstrating the software. So if you have any inquiry or any question, or you want to download, or you want any more further information about what our services and products are, you can visit our website at www.wipware.com. You can also reach out to me at blessing.taiwo@wipware.com. So the second version of this video, the second part of this video will be the live demonstration on the software. So I will be showing you how to analyze image using WipFrag, and I will be showing how to interpret the result. Thank you very much, and I look forward to meeting you in the second part of this video, where we do the analysis together in real time. Thank you. So on the mobile device screen right now, you can see a green frame. So after the blasting, all you need to do is to pull up your mobile phone and open the software interface. So you take the image in app. So the first thing you need to do if you are using iPhone 12 or above is that you align the base of the green frame to the base of the mock pile. Then you can adjust this frame to align with the slope of the material. So you can see as I'm sliding it up, is aligned. So I align the base first to the base of the mock pile, or the base of the mock pile that is closer to where you are standing. Then you align this green frame with the slope. Then if you're using Android device or maybe Samsung and the likes that doesn't have LiDAR, so you have one more step to do at where you see this wire mesh, this white frame at this edge. So when you click that option on maybe Android device, then you can identify what the height of the camera is to the ground. So when you put that in, then you can proceed in the same way. So here, taking the picture, I just align the base, then I align the green frame with the slope, then you take the picture. So in this case, the software is going to import the image directly. Then you see the scale, the auto scale length at the top. You can see the scale at the top, then there will be a scale at the base if it is slope material, if it is a material that is slopey. Then if you are taking the image, you want to make sure that you are standing on the same ground. You are not standing at the top or the top, you are standing on the same bench level. Then you take the image directly as I've demonstrated. So after this, on the mobile phone, you have the red dots steps to complete. So the next step is generating the edge detection. So now you can generate the edge detection using the simple or using the deep learning. So the simple is the old way, the traditional way of generating the net, which requires users to adjust this slider till they have a perfect spot that actually account for the net properly. So but with the deep learning, you can easily have the net generated as fast as possible, eliminating any form of error. So it takes few seconds for that to be done. So after generating the net, then when you tap on the screen twice, you can activate the heat map, which will do a characterization of the material that you just analyzed. So the heat map is in such a way that the hotter color demonstrates the bigger fragment, then the cooler color demonstrates the fine fragment. Then when you're done with that, you can edit if you have to do any editing. Then if you don't have any editing, when do you need to do editing, and how do you know those areas that you need to do editing? You need to do editing most of the time when you have a picture that is not clear enough for the software to detect the edges of each of the fragments. Sometimes maybe the picture is blurred, and detecting the size of each of these blocks is difficult for the software due to maybe the lighting system or maybe the type of image you are using. So in such case, you want to activate the heat map, and you activate the heat map on the mobile phone by light tapping twice and holding on it the second time. So when you hold on it the second time, the heat map is going to be activated. So when you try slide down, just still holding on it, sliding down on the screen, you see the heat map fade off. So from there, you can see those edges that are not well identified. So we call those edges that are not well identified as false positive. So when you see any of that, then you can use the editing tool like pencil. Maybe you need to clean some, maybe you need to retrace some, then you can retrace anyone you need to retrace. So then you can generate the particle size distribution curve for the analysis. So I'm going to do more of explanation on this on my Windows version. For the software, you can add image to the software in two ways. You can either drag the image and drop it into the software. Then you can click the plus icon. Then when you click the plus icon, if you are adding an image, just like a terrestrial image, then you can click this. Then it takes you to your computer. Then you can select the image directly. Then if you are adding a drone image, that is, you want to create auto mosaic, then you select the second option, which is this. So when you click this, it allows you to create an auto mosaic. So if you have multiple images, that is, this is my last drone flight and I'm having like 98 images captured from the blast. So you can stitch the images together to create a single auto mosaic image, which I'm going to show you the final result of this when we get to the section of UAV image. So analyzing the image, in this case, I'm going to be using a dual scale image with you. So the first limitation of this image is that the image is a bit blurred, but still yet is okay because I can see each of the fragments. So the first thing to do is to set the scale. As I've mentioned earlier, if you take the picture with the auto scale, like as you can see, the one I captured with the auto scale is here. So this is the auto scale. The software is going to dictate the scale by itself. But when you're taking this image with scale on top, then you have to use you have to identify the scale as the first option. Then I also mentioned that if you are taking the image with your mobile phone, then when you get to your window version, you can download the image you've taken before into the window version. So this allow teamwork in using the software. So if one of your team member is on site taking the picture, then you are in the office, you can download those images. So these are the images I've taken on my mobile phone, so I can download them. When I click here, I can download it from the cloud. So now I want to analyze using this image sample. So the first thing is to tell the software what the scale is and the size of the scale. So in this case, I'm using dual scale. So on the scale type, I'm going to be selecting dual scale. So then what is the scale length? That is the length of this scale from here to here is 1000 millimeter, which is the upper scale. Then the lower scale is also 1000 millimeter. Now I'm working with millimeter. You can change the units right here. So on changing the unit, I want to select millimeter. Then the next thing to do is to identify edge to edge of the scale. So click at one edge, hold on to your mouse and drag to the other edge. Then how do you do the clicking on your mobile phone? Just tap on the edge and hold on to it. You will see a bar. Let the bar progress and tell you to hold on and drag. So when the bar tells you to hold on and drag, then you can drag just as I did, just as I'm demonstrating now. But for the window version, just put your mouse on one edge, then left click, then drag to the other end and let go of the mouse. So here I'm done with setting the scale. Positioning the scale object, you want to make sure that you position the scale object almost parallel to each other. So you don't want to put the scale perpendicular to each other. The software will tell you error. It's going to say the scale is error. So I just want to demonstrate that. So assuming I have a scale object in this direction and I have another scale object in this direction, so you can see invalid scale is not going to work. So you have to have the scale parallel to each other in this way to ensure that you work with the software without the software telling you the scale is invalid. Then the next thing to do is to generate the net, that is the text, the size of each of the fragment. So you click here. So as I've mentioned earlier, we have two ways of doing it. So this is the simple edge detection, which is just like the default. So in using the simple edge detection, you just have to adjust the slider to suit the best way. So how do you know the best direction to move the slider? So if you have fine materials, that is the material is over crushed, you move the slider all the way to the front. But if you have material like this, that is you have some bigger fragments, then you move the slider to at least 75% to the center. So you can drag it to this way, then you can right click on it to activate the net. So here when I activate the net, you can see this is what is called disintegration. So this particle is being disintegrated. You can see it's broken into smaller sizes, which is error as far as image analysis is concerned. So in the previous version of the software where we only have this option, users have to use the editing tool to account for this. So right now, if I want to cancel or edit this particular block, because this is just a fragment, but in this case, the software is seeing it as 3 different particles, which is false positive. I can use tool number 5 in this case to do the editing. So I'm just demonstrating the human interaction in this case, that is you can interact with the software and do a manual editing. So in this case, I just clear that disintegration error. So in this using the editing tool, sometimes if you are using the classic edge detection, it takes a longer time. But in another way, now we have the deep learning, which can easily edit the image automatically. Then if you need to do editing, it will be minor. So you switch here at the edge detection type, you click deep learning, then you generate the net. So subsequently we do release new version of the net, that is the edge detection is being improved consistently. You can see most of those error has actually been cleaned. I only have some area here that I need to clean. So I can now start using my my editing tool to try clean those error. So on here on the editing tool, you have the first tool called the free draw. So that tool allows you to draw any net, that is edit any area where you need to draw. It's just like a pencil, so you can draw any the net to close up or to join those edges that are not well connected. So you also have the undo. If you do any editing, you can undo that. Then you have the ignore, which is tool number 7. Right now the ignore is being applied at this section, so I want to ensure that I edit this. So the software is trying to automatically identify this bar and exclude the bar from the analysis. So I can easily use the free draw to redraw this block just in this way, then redraw the block in this way. So this is just the manual interaction with the software. So you can interact with the software, then I can apply the ignore. Now I ignore that bar to ensure that the bar is not being identified as rock. Then another thing you can use in this case, as I've mentioned, you can double tap on the screen. So when you double tap on the screen, the heat map will be activated. So the heat map will show you those material that are big fragment and those material that are small fragment. So you can see the biggest material is the one shown with color red, then followed with the one with orange and the likes. Then we have another tool right here that can help you in editing and help you in accessing the blasting results in quick time. So the tool is positioned right here where I have my laser point. So on the tool works in two ways. The first way is that the tool can highlight the 50 or up to 50 biggest fragments. That is, you want to see the 50 biggest fragment and where they are positioned, so you can adjust the slider to 50. Then if you want to see the 20 biggest boulder or fragment in this blast, then you adjust the slider to 20. Then if you want to know the size of each of the fragments, just put your cursor on any of it, then right click on it. You can see this is the size of this block and this is the shape, that is the sphericity. So the sphericity in this context is explaining the ratio of the longer length and the longer width of that block or that boulder. So you can click on each of the boulder to see their sizes. Then in other way around, when you click the tool the second time, you can access the blast based on size. That is, you want to see the material range in this particular size. For example, if I want to use, if this is my blast and I want to check the number of the particular boulder in this blast that will not go through my crusher. So all I just need to do is to hold on to this. Then you can enter the size of your crusher. Maybe 200 millimeter is the size of my primary crusher. So I want to identify any of these block that will not go through my crusher. That is, I need to perform secondary blasting. Then when you put on the 200, you update that. Then the software will highlight those material that is bigger than 200 and tells you where they are positioned. You can right click on them to see their sizes. Then in other way around, if this is on a bench, I want to see where I'm having poor fragmentation. You can see more of the big boulders are actually positioned here. I can know where they are positioned. Then maybe in my next blasting, I want to investigate why I'm having poor fragmentation at this spot. Then another thing you can do with the software is for color detection. So if you are having, for example, you have dilution issue with the quarry or the likes, so you want to assess the percentage of the material that is having a particular dilution rate. Maybe, for example, you are mining spodumene and you are having granitic intrusion, so you want to see the percentage of the material that is having darkish color of granitic intrusion. So the software allows you to set two color, that is the first color for the ore, that is the ore that have less of dilution. So you need to click on it and drag to highlight those materials. So here I have two kind of material. I have those material that are whitish and those material that are black stain. So you can see there's some black stain. So the software will quickly scan through this material and highlight the portion of each of the boulder or each of the fragment that have blackish color. Then when I'm done, I set the other color for this. Is the first one is for the whitish color, then the second one is for the blackish color. So I can highlight other parts of the blast that is black, that has black stain. So the software is going to calculate the percentage of this blasted material that has whitish and blackish. Then if there's another color stain, it can also calculate that as a way of assessing dilution rates in your blast. So when you're done with that, that, you can generate the particle size distribution curve. So here is the particle size distribution curve. Here you can change or edit the name. Maybe this is from mine 2, then maybe this is pit 2, for example. So you can edit the name. It allows you to edit the name in 2 lines, maybe the name of the mine, maybe the bench. Then here also you have the summary of the analysis. So the DAT value is showing the size that support 80% passing. That is, 80% of the material is smaller than this particular size class. Then the X mass is showing the biggest boulder in that blast. Then the end value is the uniformity index, the Rosen-Ramler uniformity index, showing how uniform the material produced by the blast. So I uniformity value, that is I end value, shows that the material is of a particular uniformity level. Then the D90 shows the size that supports 90% of the material passing. Then for the color ID, remember the other time I set color ID 1 for those material that have pure white and of some white color degree. So the material that have whitish color is of 80%. Then 20% of that blasted material is having blackish stain, so as a way of controlling dilution. If you want to add other summary, you can right click on this, then you remove one of these, or you remove 2 of these, or as many. Then you have other value like the D50, like the characteristic size, so you can add them. The characteristic size is just like the central tendency of this curve at this spot. But you put the cursor here, then you right click on it, so it opens up a window here. So you can only have 6 parameters on this chart at once. So if you have an interest, maybe you have a particular summary you want to include, then you have to remove one of these, then to add that particular size. Maybe you are interested in D10. Then if in other way around you have another size class that is not listed there, then we have the DX2. So the DX2 is a 2. For example, you say you have a specification that you want to meet in your blast. Maybe, for example, you want to check the 85% passing. Maybe that's the passing size that you use as a way of assessing the blast, maybe it's efficient or not. Or sometimes, like recently, I have a training section with a team member from Australia or the likes. They said the plant manager says the DAT must be less than at least 600 millimeters. So if you want to know what a D85 or DAT is, you put it in here, then it's going to tell you the size class, that is that size class of interest. Then if it is based on size, that is you want to assess the percentage of the material that falls within the range of maybe 250 millimeter or the more. When you put it in here, it's going to give you the percentage passing size in that range. Then another way around, especially for people who are mines who are interested in using the software for specification purpose, is using the specification envelope in that regard. For example, using the specification envelope means that you have a particular size class, maybe the primary crusher, and you want a specific percentage of the material to be in that size range. For example, if this is a mine and the primary crusher of the mine, for example, maybe the primary crusher of the mine is 300 millimeter, then I have other size class of interest of 100 millimeter or the like. So I can set a specification. Maybe I want 80% of the material, at least if this blasting is a good blasting, 80% of the material should be in 300, should be within this range. That is 80% of the material is smaller than 300 millimeter. Then if possible, as a specification, everything should go through. That is, all the material from this blast should be smaller than this particular size class. So the software is going to assess that and is going to tell you when that specification is met. That is, in this case, my specification is that the minimum size range to be, that is, the minimum percentage passing within 300 should be 80 to 100, and in this case all the material is smaller than that size class. Then if you have other size class, you can include them and you can set the specification towards them. Maybe in this case I want this range to be 70, then I want this range to be 80. So the software is going to keep tracking that and give you a yellow envelope within that specification range. So it's going to check if the curve or if the material meets that specification. Like in this case, the first specification is met, but the second specification is not met because I mentioned that the material in this particular size range should be at least 70%, and now is 35%. So the size class in that range does not meet my specification. So you can edit, you can include as many size class as possible. As I've mentioned earlier, also you can edit the sieve set. If you want to add a new sieve set, you can add that to the sieve set. You can edit, it's up to 25, so you can edit. So if you want only from a particular size range, you can delete some and have it limited to your size range of interest. Then exporting the results from the software. So before you export the result from the software, you can define those things you want to include in the report. So what you need to do is to put your cursor on the chart and right click on it. So when you right click on it, the software is going to show you what you can export from the software as your report. So if you want to export the nets included, you can check it. Then all this will appear in the report that you will be generating from the software. Now exporting, you can export the report right here where I have my cursor. So if you click this, you can export the results as PDF, as PNG, as CSV file, and as analysis file. So if I'm exporting as PDF, I can mail it to someone, I can save it to my local disk. So it's going to ask me where I want to save it. So I'm saving it on my desktop. So I'm exporting this result to show you how it looks like. So this is what you'll be getting since I already specify what I want. So in this case, it's including everything that I've specified. I have the chart, I have this summary, then I have the characterization result in this case, and I have a legend for that showing what color and what the color means. Then I haven't mentioned that we also have a simple blast model, which is called BlastCast. So to use the model, you need to follow a particular step. What the model allows you to do when you turn the model on is that you can simulate your blasting. That is, maybe you want to make adjustment to your controllable parameters. So you want to see how it's going to affect the nest fragmentation. Maybe currently you are producing more of boulder, so you want to see if you adjust your burden, how is it going to affect the particle size distribution curve of the nest blast. So activating the BlastCast module right here, you're going to have two curves. The first curve, which is the blue curve, is representing the current blasting that we just analyzed. Then the red curve is the simulated curve, which we want to simulate to either adjust the burden or adjust the spacing. So when you right click right here on this box here where you have prediction, when you right click on it, you're going to see different parameters that you can change. So as you are making any changes to any of these parameters, is going to be reflecting on this red curve. So but before you make all the adjustment, people will always ask, how does the model communicate to know my exact design? So before you start making any simulation, the first thing you need to do is to fill in all these parameters based on your current design. So you want to fill in maybe the bench height of the previous blast. That is, this blast we are assessing is 9 meter. Then the burden maybe is 3 meter. Then the spacing, maybe the spacing is 3 meter. Then the hole diameter, maybe the hole diameter is 76 millimeter or 72, depending. Then the rock factor is the factor that puts into consideration the strength of the rock and the likes. So if you have the value of the rock factor, you can you can uncheck this, but if you don't have it, just leave it checked. Then the software is going to back calculate it using all other parameters and the particle size distribution curve of the current blast. So your drilling accuracy, you want to enter that. The relative strength of the explosive you are using, you want to enter that. Then the density of the explosive you are using, you want to enter that. The model use the KCO, the modified KCO model. So the paper published on the model is available here. When you click here, you can read the paper. So you can read the paper. It's not a model, but it's being integrated into the software for easy simulation of blasting. So when you've entered these parameters, that is for the current blast, then you want to uncheck this rock factor. Then the software will have calculate that factor. So when you have that, then you can start making adjustments. If you adjust anything right now, it's going to be reflecting on the red curve. So you want to make sure you adjust in such a way that the red curve shows you a better fragmentation. A better fragmentation means that the red curve is shifted backward. That is, you have the curve moving right from here. Right, you can see right now I have the curve here at the top. This is at least at the 95% and producing material bigger than the previous blast. So I want to make adjustments in such a way that this red curve move far backward, at least to this particular point, depending on my specification. Then in some cases, you may develop a specification envelope, which I'm going to show you when I show a case study of where I'm applying this study for an ISEE conference for 2025. So I'm going to show you how I apply this, an example of that. So you keep adjusting these parameters to ensure that it's, you see when I change the body, I see a good move, but I'm still producing more fines. So you balance that up if you want to simulate based on the model. Then finally on this interface is the calibration. How do you use the calibration and when do you use the calibration? The calibration is used when you have more fine materials. That is, you want to account for the hidden fines. So if you have any image that you've captured that have hidden fines, so you want to apply a flat calibration to account for the hidden fine area. So in this case, you want to select the Sweberg flat calibration. So the software is going to calibrate and account for any hidden fine in the analysis. You only apply this when you have overcrushed material in a particular image that you're analyzing. So I haven't mentioned that. I remember talking about merging images. If you have two or more images taken from a single blast, as you can see, if these three images is captured from just a single blast, then I want to mesh them together. So to mesh them together, the first thing you need to do is to select the images you want to merge right here. So you click the select, then you can navigate down and click the images that you want to merge. I want to merge this, then I want to merge this, then I want to merge this. So I want to merge these three images together. So when you select the images, then you go up here where you have three dots. So you click the three dots option. Then on the three dot option, you go to the last option, which is merge and view chart. So when you click this merge and view chart, the software is going to combine the three images together as a single image. Then you can see the chart, representative chart, just for a single blast. Then when you want to, for example, you want to compare the result of, maybe these three blasts is from different mine. So you want to compare the result. Maybe you are doing explosive efficiency comparison or detonator or the likes. You want to check how good those the blasting is. So you can select, also using the same approach, select the three images, select the three icon, then three dots, then go to the last icon. So when you have the result mesh, and in this case you want to see the result of the charts of each images, that is, in this case we have three images. So right click on the chart, then go to composite. In the composite you can select analysis, the three analysis. So here you have the chart of the three analysis. So you can see for each of the image, you can see the representative particle size distribution curve, and you know the best blast and that blast that you need to improve. So that is that about using drone image. You can also use the software to assess your STEMI material. Here in this study, I applied the software to assess the effect of STEMI material to see how the STEMI material is affecting the blast results. So in this case, we check the DAT of the STEMI material to ensure that it actually meets our specification. So the software can allow you to compare the size of multiple STEMI material. You can see in this case, I have two STEMI material. I can compare their results together. So you can see this is the different STEMI. So we were using this STEMI material before. Now we change to this and we see a significant improvement in the blasting. Now talking about drone images finally. So this is an example of drone image. This is particularly from the image I shared earlier, 93 or 97 images taken by drone. So when the software stitch the images together, this is how it's going to look like. You're going to see the image just as a single auto photo. So here you can see this is the image meshed together. So the software is going to merge all the images together. Then you can see the bird view of the blast. So here I've done the analysis, the same procedure with the image I just used previously, you follow the same procedure, then the software can help you with that. You can generate the net just like for a single picture. So in this case, the multiple drone images captured but combined together to create just one auto photo. So here you can access the blast. So in this case, I have a specification envelope to track my blast. Then this is the blasting. The best blast is the blast that falls within this specification envelope. So the specification envelope is set based on the primary crusher, the secondary crusher, the loader bucket, then the grade control sizes. So then I have this envelope set up to assess my blast. So the point here is where we have fines. So in the blast, we have some area where we have overcrushed material. So we mark those sections as fine. So I just want to activate the heat map and drag down. So you can see we have moon dust over crushed material. So if you have any image in that context, you want to apply the mark as fine. So this to number 8 is called the mark as fine. So the software is going to analyze the fine also. So after you generate the curve, you see the fine is being accumulated here. Just like the sieve analysis in the lab, you have a pan at the base where the fine material falls. So the fines are being accumulated here. You can apply the flat calibration to fit and redistribute the fine in that context. So you can see the fine has been redistributed in this case. So that's how to apply flat calibration, especially when you have fine material in the image. Then the GIX, also here you have the GIX. If you are using drone, you want to see the fragmentation on site. So the GIX icon allows you to view that on site. So here I have my analysis right here. So I just want to view it. So this is the analysis. I want to see how the fragmentation is, the efficiency of my fragmentation based on D95. So the red spot are those places where you are having poor fragmentation on site. So if you want to see each of the area of influence of black, so we have 5 blasting in this mine, and each of the blasting section is being shown on a single view as the blasting operation proceeds. So you can easily access that. Yeah, so that's all I have to show, except from the system. This is the software is also used as the human machine interface for all our online systems. So these are conveyor belt systems that assess material on a moving conveyor belt, showing the real-time analysis result, the particle size distribution curve, and has the ability to also check specification just as what the software does. But in this case, it's doing it every time as the material is flowing. So it's a real-time analysis. Yeah, thank you very much for your time.